Newton's third law, the key phrase is action-reaction. So you may have heard for every action there is an equal and opposite reaction. Those are the terms that Newton used. Maybe more useful is saying it this way. Statement, if object A exerts a force on object B, then B exerts an equal and opposite force on A. Okay. So if I push downward on the desk with a force of 10 newtons, push 10 newtons, what is the force the desk exerts on me? Well, equal and opposite, therefore 10 newtons upward. If I lean against a wall, it supports me with a force of 110 newtons eastward. What force do I exert on the wall? Force of 110 newtons westward. My son punches me in the chest. He does this quite frequently. He doesn't know what his arms are doing yet. Exerting a force of 12 newtons to the north, what force does my chest exert on his fist? Well, 12 newtons to the south. I don't know if any of you have experience with this, but if you punch someone in the face, it does hurt your hand, because the amount of force that you exert on them is the same as the amount of force they will exert on you. The forces are equal and opposite. And they come in pairs. I will say that in terms of the physics, it's not worth thinking about which force is the action and which force is the reaction. When I push a wall, we would say that I caused that force to happen. The wall doesn't cause anything. But for the physics of the situation, that doesn't matter in the slightest. All that matters is that there is a force. I exert a force on the wall exerts a force on me, and those two happen at exactly the same time. So it isn't like I exert a force on the wall, and then the wall starts exerting a force on me, like soon after that. It's instantaneous. The two forces arise simultaneously. Now here's an interesting question that everybody, that you will instinctively get wrong. Father and his little daughter are ice skating. They stand at rest facing each other with the palms of both hands touching, and they push off. So we got Dad, who is presumably larger than his little daughter, and then his daughter, who's a cute little girl. Look at her. Oh, she's so cute. And they touch hands to each other. Oh my gosh, their arms are so long. There's something wrong with this family. They touch hands and they push off. The question is, who exerts the greater magnitude of force? Well, your instinctive answer would probably be to say the father exerts more force because he's bigger and stronger. Okay? And you're wrong. And you're thinking that even though I just taught you Newton's third law. If two objects exert force on each other, they're equal and opposite. So, Dad exerts a force on the daughter. The daughter exerts a force that is equal in magnitude and opposite in direction to the force the dad exerts on her. The forces are the same because Newton's third law says so. Okay, this really confuses people because you think, oh, the dad's stronger. And so it is true that if you put a box on the floor and both the dad and the daughter were going to try to push it, the dad could probably push it with a greater force than the daughter. But as soon as they're exerting force on each other, it doesn't matter who generates the force. That's not a question for physics. It doesn't matter who is the cause of the force. All that matters is that there is a force. And if dad exerts a force on the daughter exerts an equal and opposite force on the dad. You might have Notice if you ever played that game where you stand and touch palms and push and you try to get the other person to take a step, you know that if you push hard enough, you can fall backward because, and that's just because of what we're talking about here. If you push on another person, then there's an equal and opposite force exerted on you. Now, who has a greater magnitude of acceleration? In this case, your intuition is probably correct. They'll both move backward, but the girl will have a greater magnitude of acceleration because the forces are the same and the girl has less mass. And we know net force equals ma, so a larger mass naturally leads to a smaller acceleration, and vice versa. Here's another question. Karate student punches a wooden block. Breaking it, he exerts a force F on the block. How much force does the block exert on his hand? Again, this is another thing where, it breaks. So it must exert less force, or something like that. The breaking is entirely irrelevant. Newton's third law says that the student's fist exerts a force on the block exerts an equal and opposite force on the fist. So the correct answer is F. If any of you go on to take AP Physics, on the AP Physics exam, there are often questions that give you lots of extra information. They say, oh, the mass of this thing is m, and this thing is 4 times that. And they run into each other, compare the forces, and the answer is just Newton's third law. The forces are the same. So no matter what, the force that object 1 exerts on object 2 is equal and opposite to the force that object 2 exerts on object 1. This is your homework for next class. Good luck.